Hey, and welcome to another High Performer Building Pulse. Today we are joined by Kirill from Amcrete, and we're going to be talking 3D printing of concrete here in New Zealand, and that's pretty exciting. I want to put a shout out to FMI, which you guys may, a lot of you may know as Fairview or Next Windows, but FMI are the manufacturer of those systems in the background, and have been a long time supporter of High Performer. We love their product and what they do. So thank you FMI for sponsoring this episode. And as usual, like, subscribe, and more importantly, spread the word, pass it on. And thanks again for joining us. Kirill, thanks for being here.
Nice being here. Thank you.
Yeah, obviously, you got a pretty exciting product, but why don't you tell us a bit about your journey and what led you to start doing 3D printing of concrete?
I mean, I've been in construction all my life, right? I started off in commercial, worked for pretty much all the big players in the industry, then moved on to my own residential construction, opened the business. We built quite a few houses, so anything from standalone townhouses, all sorts, high-end, low-end, mid-range, all types. And eventually, 3 years ago, I was looking at 3D printing for a while, keeping an eye on it, and I was seeing that it's becoming commercially viable. It's finally was on a level where it can be actually used on site. I decided to take a plunge. I mean, the technology behind it's quite exciting. I can see the huge potential in it, and comparing with what we're doing with our housing, our construction, traditional construction is, I won't say the best. It's compliant, for the better word, and it's not always a good thing that it's just compliant.
Yeah,
You expect something more out of it than just mere compliance, basically. And just seeing the potential, and I decided, I think it's time to move in that direction. Industry was in shambles and still is now. So 3 years ago was tough times, and we can see that it's just harder, and there's a lot of cowboys in the market undercutting, and the customers are none the wiser. They chase that lowest cost without understanding where it comes from and what it's going to cost them in the future. Unfortunately, that's the unfortunate reality at the time. So
But you were a traditional builder,
Yes.
building traditional houses out of stick.
Correct.
So you've built plenty of those sort of houses. So then you've moved into concrete, and is it because it's more cost effective, more sustainable? What's the driver for you to really do something that we're now seeing globally happening?
Well, it's a combination. You look at it as a value, right? A concept of value for money, right? What are you getting for what are you paying? And the value encompasses all those things, right? It's not just the cost, not the money cost, right? You have your obviously how much it costs you to build, then you have sustainability component, you have your longevity, durability, your future cost, your maintenance, your operational cost, your energy cost, right? And all those things together, they will create value of your house, right? And on that metric, on the overall, it does better. The concrete, solid mass concrete houses, they outperform any other houses, right? Timber houses in particular. Cost, they're competitive on the cost. 3D concrete printed houses, not if you do your traditional concrete, it costs you arm and a leg, right? It's you'll sell your firstborn, and you're still gonna have to pay more, right? It's prohibitively expensive in New Zealand to try build either precast house or cast in place, cast in situ concrete house. The labor component is very high, unfortunately. It's very labor intensive, right? So that's where technology comes into it, right? The printer takes away all that pain, right? We don't need that much labor on anymore. It prints, it just goes, and it prints that permanent formwork, forms all the walls, and then we fill it with concrete, and then we create a mass concrete house, basically.
Right. So there's a bunch of technology out there, and there's lots of different ways, right? Because at the end of the day, you got you've got two elements. You've got a printer and you've got the mix, and the technology has been evolving on both of those. There's off-site, on-site, all these different things that I've seen happening around the world. Where did you land? What have you ended up bringing to market in New Zealand?
So yes, like you said, there's a lot of different combinations. The main sort of directions the concrete printing taking is your gantry printers for the volumetric printing, mass printing, and you have your robotic arms. People use them interchangeably in some times, but I mean, the tool for a job, right?
Right.
One works better for certain things, the other works for the other ones. So robotic arms, they sort of now tend to be used in the factory settings, so they will print things in the factory, then they'll take them on site and install kind of like precast.
So they do a panel rather than...
Yeah. So it's all penalized, right?
Like the guy in Hamilton.
Yes, and then you will transport, erect them, brace and fill with concrete. And with gantry, you set up printer on site, and then you print the whole thing in place. So it's like it's just as a piece comes off as a one piece, the whole house is done in one go in place. So you don't have those transporting costs, installation costs. Basically, that takes away. You have setup costs, but again, depending on the machine. With us, we specifically chose the printer that can be handled easily on site, so you can set up and disassemble and take it away. You don't need any heavy machinery to do so.
Okay.
There are bigger machines where you end up using cranes to set it up, but then they print bigger buildings. I mean, in Europe, for example.
Yeah.
But I figured it's probably not the best solution, not for single standalone housing.
Yeah.
So for us, so we have the gantry printer, and the advantage is that we can set up on site, print it in place, avoid all the transportation costs, erection costs, and that cuts down the price significantly, right? Comparing with the concrete alternatives. So now we are on the level where it's costs about the same as a timber framed house.
Wow.
So we've been following these guys in Australia and looking at how they're doing it, and they're on the same journey as you, and they're following what's happening overseas. And it's, I guess, for people who are listening to this and you're driving home from work, basically we've got a gantry crane that is around the perimeter of the site. Is that right?
Yes. Yeah.
And then, for the want of a better word, we've got a concrete pump where we're mixing and pouring the concrete off your 3D drawing that you've created as part of your design? Yeah.
So we'll create a model, and that model then gets used to print it on site, right? So it will create a G-code, a specific file, the toolpath, and then it will, the printer will follow that toolpath and then print the building on site. Yeah.
And when you look at your website, and we recommend you do, because this is game changing, we think in New Zealand another great way to build innovatively. But when you look at how you're pouring it, and there's some good photos on there and of how you're doing it. One question that keeps coming out is insulation and the thermal properties, and that's a question we're being asked in the hub a lot.
Yeah, so we put it up on the website. There is a section, if anyone interested, they can open up how the 3D concrete printing works, and we have a cross section of the walls.
Yep.
So basically, when we print shells. So the wall is made up of internal walls made up of two shells, and then the empty space between is filled with concrete and rebar. And exterior walls will have 3 shells and 2 empty spaces, 2 cavities, one filled with concrete, the other one filled with insulation.
What is insulation?
So we use a loose fill insulation. It's a very lightweight expanded glass insulation, so it's an inert product.
Yeah.
There's no off-gassing, it doesn't produce any smell or gases, no glues involved. It's completely inert glass material.
Mm-hmm.
And this gets poured in, or?
Just it's a loose insulation, so it's like a bag of, like a bin chair stuff.
And so then what sort of R values do you get as a result of that?
We can get any R values. It all depends on the thickness of the cavity. So for Auckland we do 150 mil cavity. That gives us the required R value as per building code. If we need to be thicker, we can go thicker. We can make the wall thicker, and then it will have a higher R value.
Okay. So that's it. So you end up quite a thick wall. by the time?
Yeah,
'Cause
the
150
exterior walls,
is
yeah.
on top of your structural. How thick's your
400 exterior walls
overall?
are 400 thick.
Yeah. Does that must have other implications in terms of, joinery going in and all of those sort of depths? I mean, how do you deal with all of that sort of stuff?
Essentially, at the very core of it, you can think of it as a masonry house, right?
Right.
As if you were laying masonry blocks, but instead of blocks, you print them in place, right?
Yeah, right.
And everything else is very similar to masonry code, right? And that's the reason why our compliance is very easy. We're using existing codes, right? So we use masonry code. So basically, as if you had the block walls
Block wall, yeah.
throughout everywhere, and then you can install your windows in the same way as you install them in the block wall. So we'll install windows between two concrete surfaces, seal flashing, chase-in flashings, seal around the windows, air seals, all the usual things. And then on top you put your traditional roof. You can use timber trusses. Concrete roofs can be done. Solid concrete can be poured. I mean, because the walls are all concrete and load bearing. It's a lot easier to do than, say, with timber frame, which is impossible, right? So you can chuck some tray deck on top, pour concrete, and then you'll have a complete bunker with concrete on all four sides, with slab below you and concrete above you.
Tim, I call it the bunker's house.
If you really, really want to. But usually it's a lightweight roof, timber frame. Then we can put all our services inside the roof space, your air cons, ducted systems, wiring, all those things, and then any type of roof on the top, color steel, concrete tile, anything else you want.
When I went down to look at that, and we took 50 people down and had a look with a whole lot of developer type people, everybody came away with the same impression. You don't think about the thickness of the walls.
No.
It feels warm. It's quiet. That's probably the most thing that you come away, and it's very zen. Really, when you're in that house, it feels fantastic. Great job, by the way. And then the fit out was great and all that sort of thing. And a lot of the questions that were asked there and we're being asked here in the hub was revolved around, thickness of the walls didn't make any difference, but it was how do you put electrical conduit in, how do you do, rough-ins and all that sort of stuff. And, so how do you do that,
Yeah, so when we print, we'll place the boxes, flush boxes in the walls as we go. So basically where they're supposed to be, and then we have conduits inside the walls, empty conduits, and then once we fill with concrete, Sparky just pull the wires through the conduits. That's it, really. It's quite simple, yeah.
Yeah, that's super simple. So tell me, how about the house you've done? I haven't been there. So how big is it? What is it?
The one we've done, the initial one, the first one is 165 square meters. So that house fully fits within the printing area of the printer.
Yep.
It's 4 bedrooms plus small study, kind of like 5 bedrooms, 2 bathrooms and a single garage, large living space. So it's pretty nice, substantial house.
Yeah.
And the next one we're doing in Glenbrook, we're making it bigger than the printer area. So we print some walls inside, and then later we'll pick them up and place them where they need to be outside the printer area.
Okay.
Yeah. So that's the other way we're working on, trying to expand on what can be done.
Okay.
Yeah, so you got a limitation
So
around
with
the size of the gantry.
Yeah.
And how long did it take from you start printing to you finish printing?
Yeah.
And the concrete's in, and you really start putting a roof on.
The printing itself takes about 20 to 30 days, weather dependent. Once it's done, we put the rebar and fill with concrete. That's a couple of days, and that's it. Really, chuck the roof on. We don't have to wait much.
So a month to build the structure, the walls basically on top of a traditional slab, right?
Give or take, give or take.
Rough
So-
slab.
Yeah, normal raft slab or whatever the engineer designs for the soils, But it's the printing doesn't really impact the slab design. Slab is really normal slab for all intents and purposes. So
You're obviously further along the line because obviously it's a lot quicker to stand some frames up. But you, what stage are we? Are you effectively clad and lined? You just have to strengthen, basically, pour the concrete.
Yeah, correct. So
you're probably better. So we're better to look at that, say, 22, 25 days by the time all the concrete rebar is in.
Yeah.
So when we're at that point, other than the roof, we're already clad and lined.
Yep, correct.
You haven't got wires, but you've got
Yeah.
you must have your pipes.
Yeah, pipes are all as we go
Plumbing
again.
and
Replace
all
them.
that's in.
Yeah. So yeah, basically, yeah, you're printing. A lot of people go, oh yeah, timber frames stand up in a couple of days. Yeah, you're replacing not just frames, right?
Yeah.
You're lining, interior lining,
Yeah.
and the cladding. Yes.
Yeah.
Yeah.
So, and did you do the whole design and build on that one, or you always worked with an architect?
Yeah, we did. I obviously we have architect and engineer we work with, and they're quite proficient in their field, and now with 3D printing they have quite a bit of experience. But we can work with any designers. I mean, it's not really complicated.
Yeah, we want to show, and we'll do it. We'll do some links. Some of the stuff. I mean, I know you built one to prove that you could build a traditional New Zealand house, and it looks like a traditional New Zealand house until you go inside, and you feel the strength of it and the warmth of the house and all those things. But I think designers will love the fact that you can do these curves and you can make it really look sexy. And I know that's the next version for the Kirill universe. So I think if we, what we'd love to see is some architects reach out to you and say, hey, can we do something that really looks a bit different with the curves and that look that's what we'd love to see.
Yeah, that would be great. And I've been trying to sort of promote the capabilities to quite a lot of designers, and I met and talked with a few who are quite bright, and they quite excited with the possibilities and what can be done, and the design freedom it opens up to them. So it's hopefully, I mean.
Yeah.
So I suppose if someone wanted to go really big, you could print in 2 stages and just move the gantry.
Yeah, correct.
It's just if it's only a little bit bigger, then it's simpler for you just to print those and move
and
them
then
out.
place them outside. Yeah, correct.
Can't be that easy to move the.
I mean the sections. I mean, of course. I mean, we won't print like a 10 meters long wall in one piece. So then we have to lift it up. I mean, we limit the size to the equipment so it can be moved easier with the high-up truck rather than tower, like a mobile crane.
Yeah.
But in extremes, I mean, we can just bring crane on site and they can lift anything.
And I understand it's a technology that you don't get this very often, but can be used to build simple, affordable homes and high-end, complex, as crazy and big as you want, right? How does that work? Why don't we start with how can you deliver a really cost-effective, affordable home with this technology?
I mean, with the sort of simple one-story house, we kind of sit on around $3,000, give or take, depending on design and finishes. So yeah, it's about 3.5, which is about the same as your normal stick frame house. And then you can.
Are there things you could have done to get that price down if you sacrifice X, Y, Z? So
I mean, that's probably.
Again?
I mean, that would be. I mean, the bare minimum you really want in the house. I mean, we finish our houses to quite a decent standard, right?
Definitely.
It's all good branded like appliances, Bosch appliances, or equivalent, for example, nice kitchens, nice bathrooms, fully tight bathrooms, ducted system in the ceiling, aircon system. It's the things they don't really. I mean, it's not something you want to cut down on, right?
No, I get you, but if I'm trying to build affordable, then those sort of things might go, right? So I'm trying to, for the naysayer who's sitting out there going, well, I can knock things up for 2.5, probably not producing the same quality of home, but arguably cheaper to build. So, can you do things to get down? I know you don't want to.
No, I wouldn't. I mean, if others want to, again, the concept of value for money comes into play, right? Let's come back to the concept value for money. Cheaper is always more expensive long term, right?
Yeah.
You're trying to build middle to top end houses. Would that be fair? Middle market to top.
I wouldn't call them top end. Top end reserved for high end residential for architectural design houses. They would probably go for premium materials, and we can do that. I mean, but in their case, likely they will overlay all the concrete with something else, right? Just for the looks and feels and And it's easy to do, right? Because it's a
Yeah.
concrete substrate.
Yeah.
You can stick anything you want on it. Schist plasters, Venetian plasters. It's the whole new ball game, for the finishes that we can't do because of the timber frame, because it moves, right? And with concrete we can. But that's high-end houses, right? Again, like I was saying, value for money, right? That's what
Yeah.
I'm trying to push through to people, that they understand what means value for money. Is actually a lot of science goes into the house, right? How it performs, and that will determine when you live in it, how you're gonna live there, what you're gonna feel like, what your comfort levels will be, right? How much you're gonna spend on the house. All those things, they will come later when you don't think about them, right? It comes down through the lifespan of the house. And that's where concrete wins hands down, right? Solid mass concrete, like you mentioned before, maintenance. So no maintenance basically, right? Because you don't have cladding to look after, right? It's not timber,
Yeah.
it doesn't shrink, doesn't rot. It stays there, it's a permanent material. And that's what we're trying to push to people to understand the difference between disposable housing and permanent housing,
Yeah,
right?
lifetime homes.
European, they understood this, right? They build the houses, they are permanent, they last centuries. They pass them down to their kids and grandkids, and it's normal, it's expected. Nothing like that in New Zealand, right? People don't think that they're gonna pass their house to their kids. They don't even think they're gonna end up living there whole their life, right? And that's the expectation, right? You kind of, they go live 5-10 years, move on to the next one, and the houses deteriorate, right? They deteriorate quite quickly. You look at the houses, 20 years old, 10 years old already, they look not that in the prime
Some of them,
condition,
yeah.
right? 10, 20, 30-year-old houses, you probably wouldn't want them, right, anymore, because they look quite
Starting to get old.
yeah.
Yeah, it is funny how we consider that quite an old house, but it's not. So talking typology, are you limited to single-story dwellings at the moment, or what would it take for you to scale up and offer two-story or
No, we can
terrace houses? Could you ever do a terrace, three-story terrace house type?
the
Two-story.
printer height can go up to 7, potentially 8 meters, so we can do 2 to 3 stories.
Right.
Terraces will be a little bit harder, but we can print a set of units, right? 3 units or duplexes within that printer space. We've done a few concept designs, so we put them on the website. Your traditional terrace houses unlikely because they exceed obviously the printing space, so we'll have to keep moving the printer.
Yeah.
Won't be that cost effective probably.
So there's where's the cost coming from in moving the printer? Like, is it time? How many days does it take to set it up?
I mean, time, labor. I mean, you pack, unpack, set it up, basically calibrate everything. Just takes under a week probably to get the whole thing up and
Right.
running.
Yeah.
Less than
But it's
a week,
probably
yeah.
a 10 grand cost, right?
Not,
every time
not
you move
really.
it.
I mean, not probably not that, but yeah, it is cost and time obviously. So
it doesn't
It's
sound
not a
bad.
lot of money.
not a lot of
if
money,
you-
but
to me.
Yeah, if you're
It
building
works.
a house and you move it on to the next one and then the next one.
yeah, it's okay if it's houses,
Yeah.
but for the like townhouses, it doesn't really work that well. Especially because you print, then you have the previous structure in the way, and then you have to print next to it.
Gotcha.
So there are limitations, right? So you can't print
Okay.
the stop wall and continue printing it again when it's up there, because it will clash with the printer.
Okay. And yeah, and so you could do multi-level standalone houses. That's not a problem. So then we kind of wrestled with the affordable housing piece.
Yep.
What about the other end of the scale? You know, like we do see online some really cool architectural homes being done out of 3D printing.
Yes, and
They're
that's
incorporating the
yep.
landscaping and the
Oh,
pool
I love
and
it,
the
mate.
everything is super, like they're leaning into it as a medium. You know, I suppose what's my question? My question is, can you do that, and what's stopping it? Is it just a matter of finding an architect that says I want to do it?
That's just a willing someone willing to go there, you
Yeah.
know, and do something like that, and we're more than happy to do it, you know.
What do you think stops them at the moment? Is it they don't realise it's available, or they're nervous about it? or
I mean, it's hard to tell. Could be a cultural thing. I mean, people used to the way things are done, and they more often than not they go, I want a house similar to that house over there or this
Yeah,
house
yeah.
over there. You know, it's yeah, of course. I mean, look, high end easily can be done, and in design again, because there is no design restriction, it can be any shape and form. You know,
Yeah.
that's the thing. I mean, we have some beautiful examples from overseas. The people done
Yeah.
some amazing buildings and the structures, the 3D concrete
Yeah.
painted structures.
And we'll show on we'll do the thing on
Throw
this
some
one in
stuff up.
Australia, and
Yeah.
it looks amazing. You can do that with
Yeah.
your technology.
Yeah, of
So
course. I mean,
if I'm an architect, then I'm going, okay, I could let my mind go wild and draw something as crazy and beautiful as I like.
Yeah.
My concern is I then have pitched something to the client that what I don't know about is how do I execute on that? Is this something that I'm now going to spend hundreds of hours because I'm now working with a medium that I'm not experienced with? I don't know how to detail all the different bits. I don't know about, this and that and the engineering and the wind loads and all these things that I kind of know in the back of my head from my standard building methodology. My guess is that either of those things are easy or you're supporting that process. What would you say to me as an architect who's going, I love the idea, but I'm really concerned, I get a fixed fee and I'm concerned this is going to cost me thousands of hours. What does this look like? How do you
well, I
deal
mean,
with that?
for architect, it's probably not that complicated. Once they come up with a shape, right?
Yes.
Everything else follows, and its structural part is not that complicated. Again, it's a solid concrete wall at the end of the day.
It's somewhat over-engineered by the sound of things.
Oh, I mean, kind of, yeah. I mean, the code has certain requirements, seismic requirements, and that's probably
Yes.
another reason why the concrete and bricks are not common in New Zealand and timber frame is. But yeah, there are seismic requirements for the walls, and engineer deal with those ones. Again, nothing overly complicated. Masonry code and concrete code comes into play. Pretty straightforward from compliance point of view and design point of view. For engineering portion is not complicated, and we're happy to support them and to guide them in how to get things
And
done.
the integration of all the other elements, okay, I want floor-to-ceiling marble in my bathrooms, or I want, some special lime wash plaster, or what you call Venetian plaster.
He did it.
Yeah, sure, but I've never detailed that
Yeah.
before. You're saying that's just pretty simple. Have you got standard details about all the integrations of these various products?
I mean, main concern always is your weatherproofing, right, and how your elements fit in together to create the weatherproof shell, right?
Mhm.
That's windows, but
Yep.
on that front it's again simple because it's a
Yeah.
concrete
Yeah.
surface, and then you install the window next to the concrete surface. So that's very basic detail. It's already in the code, so nothing special there.
Yeah.
Other than that, I mean, you don't have to concern yourself with cladding or anything else. It's just the windows and the concrete.
Yeah.
That's it, really. And inside finishes, that's normally you get your right tradespeople, and they know their art, and they will do their job. Like plastering, all those
Yeah.
things. Again,
Yeah.
from the designing point of view, all they have to do is specify what they want, and then you'll have trades. They'll come.
But
in
you're
and do it.
fixing to a
Yeah, you
brilliant
can-
substrate, aren't you?
Exactly,
I mean,
it's a solid concrete,
Yeah.
solid substrate. It's all you can use any glue. It's all sticks there.
Yeah.
It doesn't move, so you don't have to account for future movement and worry about things falling off the wall.
Yeah.
But so with all of those finishes and all that, to me, it's actually easier for the architect to design because basically he's just designing formwork, a concrete structure.
Yeah, just a
And
shape
then
that's
he
it.
can fit, if he wanted to put a brick veneer on to make it look,
By all
put
means,
green
yeah.
bricks on it, he can do that, right?
Of course.
It's easier.
Yeah.
So we were talking before we went on, and I was quite surprised. You were saying that there's been modelling done that demonstrates that actually the life cycle from a sustainability perspective is that it's showing a better sustainable. I'm sure is that a carbon story, but on a concrete home over a timber home.
Yeah, correct. So the study done in 2024 here in New Zealand, published study, they've compared 3 types of houses, 3D concrete printed, timber framed and light gauge steel houses, and they've done the life cycle assessment of the emissions of the whole cycle of the house, not just construction or operational costs, right? And it's all, they tallied it all up, and concrete ended up about 20% lower than the timber house
Right.
throughout the
incredible.
life, right? It's includes everything, right? So production, construction, disposal, everything, and operational costs, everything is there, right? So they've
Did
tallied
they
it up,
swap
yeah.
over at the different parts of that journey? Do they show that in the study? You know, I suppose.
Yeah, they all
Yeah,
split into sections. You have your construction CO2, you have your pre-construction, you have operational costs, operational CO2, right? Energy costs, and you have your recycle, disposable, and post-life use of the leftover whatever materials.
So what did it look like post-construction embodied carbon across those three models? My assumption is that concrete was higher at that point, and then over the rest of the life cycle, it comes down. Am I right about that?
Not really. I mean, CO2 with concrete, it's sort of lower in all respects, really. Even the very old study in 2000, I think it's 2002 or something, they've done mass concrete versus timber. That was not 3D printed, mass concrete.
Yes.
The energy input to make those houses, they didn't count CO2 at the time. The energy input to build those houses was same.
Yeah, but it's
Mass
not
concrete
yeah.
versus timber, not CO2.
What are we talking? So what are we
Joule,
talking?
joule.
When we're
You've
talking
also
energy,
but
Energy.
you also to create concrete is a lot of energy required to create concrete. So some of the English studies they factor that in, don't they?
Yeah.
Where you're just talking about the manufacturing of a material and building the house. And that's
No, if they
no,
don't
the
full
la- the
life
late-
cycle
like
though,
life
they
cycle,
would
it
be
includes
so
going
they
the
take that
cradle.
into account.
Everything included life
You know, the
cycle.
Portland
means
cement. You know,
from very beginning where you source everything to the very end when you dispose of everything, and all again we have the
Yeah, we'll have to put a link to that.
Yeah, 'cause
put the
architects, I don't
link up,
think
put the link up,
Yeah.
and then people can actually read the whole thing. Again, it's amazing, but it shows that concrete outperforms concrete houses, right? Lower CO2 emissions. That's based on the same lifespan of 50 years, right?
Right.
They say, okay, we're not gonna argue over lifespan. In reality, your concrete lasts a lot longer, right?
Yeah.
So
A
the
lot,
lifespan of concrete in 150 years, that's probably accepted. Could be longer. When you actually take that into account, right, it drops 3 to 4 times, right? So your emissions, because the
of course.
lifespan becomes,
Yeah.
when you take the lifespan into account, it becomes, so you're replacing 3 timber houses with 1 concrete. By the time you demolish concrete house, you have to do another 3 timber houses.
So their model basically assumed at 50 years, all the houses were being demolished,
Yes,
and
that's
then
the standard.
Yeah,
Going
but
to
in
the-
reality, with concrete, you
Yeah.
won't need to, right? It will
but
still
I
be
can see
useful.
where that.
Yeah.
Yeah.
Yeah. So when the metric becomes the updated metrics becomes CO2 per year of service life, right?
Yeah.
And then when you take the year of service life into account, it becomes completely different picture, right?
Yeah.
The concrete just wins hands down. And even though it's like a lot of times it's quoted, the concrete accounts for 8% of global CO2. Well, it's because it's so good that
And
we're using it so much of it, and that's why it's so high, right? If you were to replace all concrete with something else, it would have been even worse, right? It would have been even higher.
We just had the concrete guru on, didn't we? And he said it's the second most used material in the world other than
Exactly.
water.
Yeah. Like,
So of course it's got, you know.
of course, yeah, you have high, but because it's been used so much.
Yeah. Okay.
So if I'm sitting there listening to this, gonna be building a house. Now it could be someone's building their own house, but inevitably we have builders and architects listening in the audience. So they're always building houses. What do you think? Let's just put homeowner on. You know, I'm driving home, I'm listening to this thing, thinking that sounds pretty cool. My immediate thing is probably, it also sounds scary. I don't want to be the guinea pig. Sounds like a good idea, but it feels a bit safer. I'll just go to my normal builder or architect. What do you think people need to hear to overcome the fear of trying this new thing?
Well, again, that's why we've done show homes, and we keep trying to build things, right? To show it's not a new thing, right? The concrete itself, it's the oldest building material, right? You have Rome that still stands there, right? Concrete structures all over the world, and it just sounds new.
Yes.
3D concrete printing, but it's not new.
Right.
Concrete printing, the actual invention of it was done in 1930. There was the prototype machines. There are videos on YouTube where people were using machines to actually print the buildings with concrete, right? It's not new. It's not a new idea. It's just that technology finally caught up with what we wanted to do, right? So the capability is there. So it can be done, right? Technological advances allow us to do this.
I mean, I suppose the thing is, it's just that it's, my encouragement for people, having gone through this conversation, is moving beyond that's interesting to, could I actually use it? And what are those next steps? Is, to me, what you're saying is, I think it's really valid. It's not that new in terms of, the detailing and compliance and that sort of thing. We're not creating a whole can of worms and headaches with that. And like you say, you are adaptable and open, and so it's essentially just pick up the phone, talk to you, and go see the show home and, explore it. And you might still get to the point where you go, it's not for you, but it's not as big a jump as I think people might immediately think.
In a sense, it's actually simpler than your traditional construction, right? The walls where in normal house you have frame and then layers upon layers of things on them, right? You have jib, you have paper, you have cavity, you have your cladding and then flashings and whatnot, right? And the windows and all those junction and interactions. With concrete, it's just solid concrete. That's all to it. That's it. It's just solid concrete. It's actually simpler construction than your traditional housing, right? So it's safer.
Those homes you see in Texas, and they build 100 homes in 10 months or some ridiculous thing, and they're beautiful homes, right? And they're white and and they look really cool.
Exactly.
And they were cost effective by American standards. And so I'm with Tim. I think there's some, because I've been through the house, I love it, and I think it's a great way to build. And I think if you're in the long term thought, a lot of Kiwis turn their houses over every 7 years.
Yes.
But if you're thinking long term and you want to build a house for your forever house, it's a really great option. And it's beautiful. It feels like a castle, or it feels like it's going to be there for a long time. And you haven't been through, and you need to get down there and have a look, mate, because you're Mr. Innovation. So we need to. But when you go through it, and we had about 50 people through from the Chinese community.
Yeah, and we had more with the.
And how many people you're doing show homes every?
I don't count them anymore. And the testament to this, you saying this, is actually we had quite a few guys coming in, ex-builders, right? And they go, I don't really want to touch timber frame house anymore. I want concrete.
Yeah.
And so we're talking.
Yeah.
But their feedback was like, finally we have an alternative, right? Finally I can see something that I feel that will be safe to have, right? So if we build this house, we know it. We're not going to have leaking issues, any sort of issues, just because it's a concrete. And a lot of builders, they understand concrete, right? Sometimes it's hard to comprehend, right? Why is concrete better? Why is it better?
Yeah.
Well, it's just a permanent material, right? And that's what you want. You want a permanent in your house, so it stays there. And that's what their feedback was. They go, great, sign me up.
Yeah.
I can see why. I can see the value in it.
Yeah, I mean, you think, we build a timber house, and then we basically, this is our structure of our building, and then we go to a lot of effort to make sure that it stays dry.
Yeah.
And
it's hard work.
Like
we need good builders.
You've got to really look after it, because it's a material that's not actually going to withstand the elements.
Yeah.
Well, it's perishable, isn't it? It's at the end it degrades, and that's it, isn't it?
And if the builder gets it wrong, or something goes wrong with the internal papers, all the building the frame and getting all that right. I guess in your case, if we get the concrete mix wrong, that could be a problem. But there's a lot less things to go wrong.
Yeah,
leaking
pipe.
Exactly.
Leaking pipe in the timber house can wreak havoc on you, right? It destroys your frame.
Yeah.
This one have a leaking pipe and then nothing. It's a concrete, right?
Yeah.
Good point.
Right,
yeah. All you have to do, you pull it out, replace the pipe, and that's it, isn't it?
So we've got a question from the Hub people. They want to know: would you recommend aluminium joinery versus PVC joinery like the Europeans do? Where would you sit on that one?
I mean, I didn't look into it really much. I mean, aluminium is prevalent in New Zealand, and the reason for it probably because of stable material and UV environment that we have. PVC had a bit of a bad rap in the beginning. I know they improved a lot, and they made it a lot more stable now. But PVC windows, I think the cost is a bit higher. That's why people normally go for the aluminium. Now it's thermally broken aluminium. It's mandated, right? So we're using all the windows as thermally broken windows.
Yeah.
So a lot better R value. Essentially, I would say, I mean, Europe has a case for it, right? Temperatures is a lot lower, so you'll have triple glazing, and then PVC comes into play as a better insulating material than aluminium. So again, it makes sense there. In New Zealand, it's more of a choice whether you want PVC on aluminium, whether you want that look or a different look. But both work well.
But from your, there's no, you don't really care in terms of integrating with your system, doesn't
not really,
change a thing.
That doesn't really matter for us. Both works well for us. So.
Yeah. Well, Kirill, I always make an effort to thank our guests because we're really passionate about innovation in the industry, and that takes people to, be bold and do something different. And, you didn't invent 3D printing, and it's been overseas, it's been evolving overseas for years, but it still needed somebody to put their balls on the line, excuse my French, and go, I'm going to give this a crack.
Yes.
And we just want to thank you for being that guy and bringing the technology to New Zealand. And undoubtedly it's been an investment and a challenge. And from us at High Performer, we're just always really respectful and grateful for people who will push out to try to do something new. So really appreciate your efforts.
Yeah, the machine, the printer itself is only a half job.
Yeah,
it's the technology, but the how you use it, how to build a house is very different. What we learned in New Zealand, you could never learn anywhere else in the world. The way things done here, we had to reinvent the whole thing.
Yeah,
it's there are no alternative for anywhere in the world. Right? The way they do things overseas is completely different, and they don't have as many hurdles as we have here. So really, we had to.
Sounds like you still need a good builder,
done.
right?
We developed the whole thing from scratch,
But do they need a builder? You are the builder, right?
I am the builder, yes. I am the builder, We're a master builder.
So at this stage, it's not like they come to you, you provide it, and someone else builds it. They come to you.
We look after the whole thing, of course.
Yeah, brilliant. Well done.
Lovely.
Thanks again for joining us on this High Performer Building Pulse. Thank you again to FMI for sponsoring this podcast. And again, thank you to Kirill, and applaud all your efforts. And we'll catch you all on the next one. Cheers.